So hey everyone, today we are discussing about the full adder. When we have a more than two input, so to add these inputs, we require full adder because we can only add two digit with the help of half adder. Okay, so half adder only used to add two of the input. So if we have more than two input, but we use full adder. So how we made the full adder? Basically, we have two half adders here. So, in a half adder, we have two things. One is sum, one is carry. So, the sum of first half adder is goes to the second half adder. And finally, the sum of the second half adder is the final sum. And the carry of both the half adder is connected with the OR gate. And finally, the output of the OR gate is behave as your carry. Okay. So, you can see the circuit diagram out here. So, we using a XOR gate, and the output of this XOR gate is connected with another XOR gate, and the third input is given to the second XOR gate. And similarly, we use a AND gate out here. Okay, the AND gate have a input from output of XOR gate and one from the C. And finally, we have one more, you can say, AND gate here, and this AND gate is given to input A and B. And then the output of both the AND gate is connected with the OR gate. And finally, from the OR gate, we got our output. Okay, this is the C, this is your carry, final carry, and this is your sum. So what happens when we add three inputs? So 0 0 0, in this case we get sum as 0 and carry is 0. When we have 0 0 1, so that means any of these input is 1, we get sum 1, carry 0. And any of the, if we have two input ones, see 0 1 1, we have sum 0, carry 1. Okay, it will repeat again. So in the final case, we have to check 1 1 1. When we have all the inputs 1, then what we got sum as 1 as well as the carry is 1 in this case. Okay, I hope you understood the circuit diagram. Now we stimulate this on multisim, as well as we will do it on breadboard also. Okay, so first of all, we discuss about the multisim. So just I zoom it in a little bit such that you can able to see it. Okay, go to place component. In this component, you have to choose one OR gate. Okay, we require a OR gate. Okay, so we just select OR gate. We require AND gate, so we just choose AND gate. Okay, this is our AND gate, or either this kind of combination you can choose. So I'm just choosing the simple AND gate out here. Okay, we require two AND gate, and one is our JOR gate. Okay, uh, so we use a JOR gate out here. This is our my JOR gate. And finally, we require VCC. Okay, VCC I require here. So just I click VCC for input 1, and I need ground for my input 0. Okay, this is my input 0. And we require SPDT. Okay, these are the switches we require. We just flip it on later on. We require probes. Okay, I just require some probe. Let's say I choosing any of the color you can choose out here, red, yellow, green, whatever you like. Okay, green, whatever. So let's say I choose probes. How many probe we require? Two. Okay, just copy it again. So just copy it and paste. Okay, we need two probe. We require two AND gates. So copy paste again. Okay, we require two JOR gates. So again, we require a copy paste option out here. So uh, this VCC, we just shift it a little bit such that we can easily make the circuit diagram. We shift the VCC here, and we shift this ground also a little bit. Okay, here we shift this ground. You can see easily how I'm shifting this. uh, this copy it, flip it. First of all, what we do, we just flip it horizontally. Okay, just flip it horizontally, just copy. We require three inputs, so we need three of this SPDT switches. So three inputs out here. I just using this, you can see out here. You can easily do it with me also, such that it will become easy for you to make this XOR gate. Okay, so first of all, we require the output. The output of these AND gate is connected with this OR gate. Okay, for carry we have this kind of diagram, and this output is connected with a probe, this LED. And we require two JOR gate. Okay, so little bit I'm shifting it here, and one JOR gate I'm shifting here. Okay, such that it will look little bit symmetric. You can see the final output of this JOR gate, you can put it out here as well. So the final output of this JOR gate is behave epson. So x1 is sum and x2 is your carry. And the input of to this JOR gate is connected with one of the JOR gate, and another is connected with a C. Another is connected with C. Okay, just choose this path. Okay, this path I'm choosing. So this is the input we given to this JOR gate, and this JOR gate have an input one from here A. So the inputs are A, B and C. You can see it easily. Okay, I just zoom it little bit such that you can see it easily. Okay, this is my condition. Now the input to this JOR gate, this one, this AND gate is given from one of this output of JOR gate and one from the C. So I just connected it with C as well as the output of this, XOR gate. And this AND gate is given two input, one from here A and one, just click it here, out here. Okay, and one from here, you can see one is from here. Okay, so this is my combination. Now I give the inputs. So this is for 1 and this is for 0. So first switch is connected with 1 and 0. Again you have to connect the second switch. Okay, so what I'm doing, just see second switch and the third switch. Okay, so 0 is given to all the switches. Now it's 1. Okay, 1 is given to the second switch also, and 1 is given to the third switch also. So I just connected VCC with all the switches, one terminal of all the switches, and 0 is, that means ground is connected to the other terminal. So I hope the upper one is for +5, that is 1, and the lower one is for 0. Okay, that means ground. So what I see, I just stimulate it, and whether what we get a result. Okay, so I'm starting from the first one. I'm giving 0 0 0 input. So when your input is 0, see all the switches is connected to the ground. So that means A, B, C, all the inputs are 0. So in this case, both the sum and carry 0. Okay, if I'm giving 1 as input, 1 0 0, that means any of the input is 1, your sum is 1 and carry is 0. Now if any of the two input is 1, see any of the two input 1, you have your carry is 1 and sum is 0. And the final case, when all the inputs are 1, you can see all the inputs are 1, in this case your sum as well as the carry both are 1. So this is the complete circuit diagram. Okay, we can stimulate this in a multisim as well as do in the digital IC trainer. And if this same we do with the help of ICs, later on in the other videos you got all the information regarding this. Okay, so kindly watch this. If any doubt, you can ask in the comment section. Thank you. Have a nice day, everyone.